So this is why I'm asking of you guys. I'd like you to grab your calculator. And do what I did, stat and edit, and enter what you see in the table as X values, as Y values, and put them in L1 and L2, please. You want, I can show you my calculator, or you can. If you have your hand out, you can refer to it as well. For some reason, I got a blank space toward the right when I printed this, and I'm not sure why. But I didn't have time to fix this before the session today. So put 5.2, 7.3, 6.7, 5.9, 6.1, 8.3, 5.57 in L1. And then let's do the rest in L2. So second key with Y equals, press enter. And you see the on is blinking, that means it's off. So press enter again. Now on is selected. You do this once, guys. You don't have to do it every time. And then I would like you to use this arrow key where I'm pointing to and just go down and select the first one. Mine is doing L4. Yours should be L1, L2, but I'm just going to change it to L1, L2 because I'm using L1 and L2. Okay? Any questions, guys? So second key, Y equals, we turn on the stat plot on, and then we select this type, which is called the scattergram. And then you can quit, guys. You know how to quit the calculator. You see where the blue key is. So it's a second and quit. Okay. Now let's show you guys how we can show you the scatter plot. I'd like you to go to zoom right here. And then scroll down to number 9. As you can see, it says zoom stat. Okay, enter. And here you go. This is the scatter plot. Just let me know if some of you were not able to get this. All right, so this is the scatter plot. Okay, so this is how you do it again, guys. First of all, you go to stat, edit, and enter L1 and L2 in there, the information from the calculator, from the table. X values and Y values. The L1 has the X values and the L2 has the Y values. Then after that, you do second and Y equals. And then press enter. You make sure that on is selected. You turn it on. Then press enter just to make sure it is selected. And then you scroll down and then you press enter as well. And then you quit. It's going to show you L1 and L2. How do you quit? You just quit like that, second and mode. And then what we did, zoom, and then number 9. Okay, guys, so there is, as you can see, you agree with me that there could be a relationship, a linear relationship, and it's a positive one because the slope seems to be positive. The lines, there is a line of best fit. You agree with me that it doesn't fit every single point in here, but we can draw a line of best fit. So this is an example, guys, in how to do a scatter plot and tell if X and Y are related. We say here X and Y are related by a linear relationship, and it's a positive one because, as you see, the X values go up, the Y values go up. But how strong this linear relationship is, guys, we're going to find out by finding a new value in the calculator. It's called the correlation coefficient. And I'm going to show you how to find that. And once we know how to find it, I'll tell you how to use it to tell how strong the relationship between X and Y. So here's what I like you to do on your calculator. You're going to do it once, guys, for the remaining time of the semester. But if you reset your calculator, you have to go back and do it. So let me show you what I like you to do now. I like you to press the second key. So I did. And then go to number 0, right here. You should get this. We good so far, guys? You see this? I like you to scroll down until you see the word diagnostic on with the arrow key. And how I scroll down with this, guys, right here. Scroll, scroll, scroll until you see diagnostic. You only do it once, but if you reset your calculator for whatever reason, you have to do it again. Diagnostic on, and then enter twice. That's it. No, you don't do this in all the questions. You do it once and that's it. Whatever you did today, that's it. So some students are asking me if we keep doing this. You just do it once. Okay, so diagnostic on. And now, guys, let's do this together. This is something that I'm going to be doing over and over so many times. So don't worry, you will see me doing this again. Just in a few minutes, we're going to do another scattergram. So you did that. I'd like you now, guys, to press stat. And everybody, I'm assuming that you put the data in L1 and L2. If you didn't, nothing is going to happen, guys. I'm assuming that you did those X and Y values, X and Y in L1 and L2. Okay. Let's see, we have a question here. Oh, the title of those steps, how to find the correlation coefficient. It's given in the handout. Everything is given, so don't worry. Even if you're not taking notes, you don't have to take notes, guys. I have a very nice handout. All the steps are illustrated in the handout, but just demonstrating right now. Okay, so what did we say we do? We press on stat, we press on calc, and go to number 4, guys. There's going to be a surprise for you there. Enter. Okay. Some of you are not going to see this screen. You press enter again. But if you see this screen, I should select L1 and L2 myself because I put my data in L1 and L2. So I'm moving here, second, and then number 2. And I like you guys to hit calculate. Do you notice the equation of the line, guys? Y equals ax plus b. We call it mx plus b. In the calculator, they call the a m. The book calls it m. So it's ax plus b. A is the slope and b is the y-intercept. So you got the equation of the line. Let's write it down. It's already written actually here, but I'm going to just write it right here from... Okay, if we round A to 2 decimal places, guys, so what do we get? 1.26 x plus b. Rounded to 2 decimal places, it will be, the 9 goes up to 3, so it will be negative 3.3. I got the equation of the line. Okay. But I'd like you to look at something else. Do you see a value of R, guys, here? Do you see the R? 0.97. And let me tell you the importance of R. Usually, actually, this is the first question I will ask you on a test for chapter 9 to find me R. So in order to find R, guys, you put your X values in L1, you put your Y values in L2, and then you go to stat, calc, and this number 4, and then you should get R. But let me tell you how to interpret R. So R is 0.97. Can everyone see this value, guys? If you didn't have the R values, that means your diagnostic was not set up right. You had to press second, Amanda, and then 0 and go to diagnostic and press enter twice on. I can show you later how to adjust this one. It's no problem, but it should show R. We're not gonna find R by hand. It's a lot of work, you know, just to do this. Okay. 0.97. Let me tell you what that means. This is called the correlation coefficient from the sample. I want you to understand this very, very well, because usually this chapter 9 has only 5 questions, and this is the first question I usually ask. Find the correlation coefficient R, and what can you say about the relationship? If R, guys, is very close to 1, which is, it is 0.97, we say that the relationship between X and Y is very strong and positive. So there is a strong linear positive relationship between X and Y. And let me show you where I wrote this down, guys. It's in the handout. I'll show you the summary right here. If R is very close to 1, we say there is strong positive linear correlation between X and Y. If R is very close to -1, we say there is a strong negative linear correlation between X and Y. If all the points fall on the line, then R equals 1 or R equals -1. Let me give you an example, which is in real life, this doesn't happen. Perfect situation. Do you guys agree with me that I can fit all those points on one line? Yes or no? So if this is the case, guys, look, this is the line of best fit. R is 1. This is in an ideal world, you know, just everything fits. Let me give you an example where R is -1, something like that. You see, guys, if I draw a line, all the points fit. In this case, we say R equals -1. These are ideal situations, but they could happen if the relationship, we call the relationship to be perfect here. Okay, now if R is close to 0, guys, that means the linear relationship is very weak. And let me give you an example of a linear relationship where it is weak, something like that. Watch. Dots are scattered all over the place. You cannot tell whether it is a positive or negative. I can assure you here, guys, R is not going to be close to 1 and is not going to be close to -1. As I said, we will not calculate R by hand. You can use a calculator to find the value of R. But for people who do not see the R value, that means they have to go back and do the diagnostic turn it on in order to show the R, but it will show, no worry at all. What I'm gonna do, guys, I'm gonna show you some examples, and I would like you to try to guess the value of R. For me, it's from the book. Let's do this exercise together. Okay. You see, guys, the first line, you see what he puts, R equals 1. Do you agree with the finding that R is 1 in this case? Because it's almost perfect. It's perfect. All the points would fit on the line. Now I want the students try to guess what would you think the value of R in the second one. Do you guys agree with me? It's a positive because it looks like as X moves to the right, Y moves up. What's your guess for R here? Any guesses? I'm gonna hide them from you. Let's see what students are saying here. Oops. No, that can't be weak. That's not weak. There is a relationship. Weak means they have to be scattered in a way that you cannot tell whether it is positive or negative. So that is not weak, guys. That is a strong relationship, probably close to 1, 2. That can't be a 1 because a 1, it has to be a perfect relationship. So any other guesses? It is positive. It has to be between 0 and 1, and it has to be close to 1. You want to see what the R here? Let me show you the R. 0.81, guys. So it is a strong positive correlation. It is close to 1. Now I like to look at the next one. And I really need someone to try to guess what do you think R. Would you guys agree with me that R is going to be smaller than the second one and the first one because it looks like the dots are more scattered and they don't seem to fit very nicely on a line. So any suggestion, what do you think R would be here? It's a positive. It looks positive. Don't be afraid of guessing, guys. I'm not going to penalize it. 0.4. It can be negative. That's not negative. It looks like it's a positive relationship. And -1 means very strong. -1, you guys, you're mistakenly thinking that negative is bad. As long as it is close to -1, that's a very strong negative relationship. It's only when it is close to 0, the relationship is weak. Okay, I agree, 0.4, 0.5, let's see. Oh, wow, guys, you were very good. It's between 0.4 and 0.5. Let's look at the next one. Okay, what is it in this one? That should be easy. That's a perfect negative relationship. -1, very good. Very good. This is very strong too, guys. Look at the next one. I won't ask you to find this stuff by hand like that, but it's good, guys, to do some practice and try to guess the values. That looks very strong negative. So what do you think? It's negative. You can give me a positive number here. What do you think the answer is? -0.8. You know what? I think it's a little bit stronger probably in the one in the middle that we did before. So anyone want to up their answers a little? Okay, 0.9. Let's say -0.9. Let's see what it is. Very good. -0.92. Last one. Last one looks worse than this one right here, as you can see. So it doesn't, I can't even tell where to go in which direction here, guys. You remember, if it is very close to 0, that means the relationship is very weak. And you agree with me that it is extremely weak here. So any guesses? Let's see. -0.2. Okay, let's see. It's 0.04, guys, as you can see. Okay, let's show you some more stuff, just to give you a feel of how we're going to be using this stuff. Okay. What would you say about the relationship in number 9, guys? Between X and Y. If I ask you to say it in few words, what would you say? Strong negative. Okay. Strong negative. Exactly. Very strong, actually. You can say very strong negative relationship. Yeah, that could be very close to -1. I don't know what the exact answer, but it's close to -1. What about number 10? Does it look like a line, guys? It doesn't look like a line. This is not a line. This is a curve. They call it a parabola. So you say here, no linear relationship. It has to fit on a line. What about number 11? You should be able to tell me what R is here, actually. What's R here? Let's see. R is -1, I agree. And this is a perfect relationship. What about 12? You should agree, guys, 12 is very weak relationship, linear relationship. Exactly, very weak. You can even say very weak here. What about 13? Very strong, not weak positive, very strong positive. It's not weak. This is, look, they look like very nicely fit on the line. So that's very strong. And number 14, it's a perfect positive linear relationship. And I can tell you what R is here. R is 1. If you ask me to guess R for 13, guys, I tell you probably 0.9293. If you ask me to guess R for number 12, I'll tell you probably 0.1. It's very weak. And 11, it's easy for me to guess. It's -1. That's how you can tell if there is a relationship between X and Y. Okay, we're gonna do another exercise. That's a nice exercise. Okay. Let me just zoom out a little and show you this exercise. Okay. We're gonna do this together, guys. And exercises 15 to 18, the scatter plot shows the results of a survey of 20 randomly selected males ages 24 to 35. Using age as the explanatory variable. Okay, first of all, guys, this is called the X variable and this is called the Y variable. They call the X variable as the explanatory variable and the Y variable is called the response variable. Independent, dependent. Independent, dependent. So, using age as the explanatory variable, match each graph with the appropriate description. Explain your reasoning. So you guys, you have A, B, C, D, and you need to match it with 15, 16, 17, and 18. I'm gonna give you a couple minutes. Age and body temperature. I'm assuming, guys, if we are all healthy, we should have the same temperature, very much the same temperature. Which graph illustrates that regardless of your age, your temperature is very much the same. It doesn't fluctuate. Which graph do you guys think? Is it 15, 16, 17, or 18? 18, I agree. Look, guys, no matter what your age is, watch. No matter what your age is, your temperature is right below 100. Look like that. So actually age and body temperature is 18. Age and balance on student loan. Which one did you choose? Let's see. I got 16 and 17. Actually, well, here's one thing, guys. Actually, with age, your balance is gonna go to zero eventually because you have to pay it off, you know, just as you move on. So I would say it's 17. You have a lot of balance, and then by age 34, hopefully your loan will be paid off. Why 34? Because usually loans are over 10 years. So I would say 17 for this. You can see what's going on, guys. With time, you start paying, you know, just your loan off. Actually, you have to start paying as soon as you get it. C, age and income. That should be easy. Remember, with seniority, people start getting paid more. So what do you think C is going to be? Yes, 15, I agree. And we're left for age and height. Yeah, it is 16, guys, whether you like it or not. But with age, guys, people start having back problems and bent back. So height, you know, just tend to go a little bit smaller here. It's not much smaller, but it does. It does. So, all right. So that's the question that I wanted to do, and I'm gonna go back to the sheet now, guys, with you and discuss. So, what we learned today. I'm going to go very slow with this so we understand what to do. If you are given a scatter plot, guys, two sets of data, X and Y, you should be able to put them in L1 and L2 and find a number that we call R. This is called the correlation coefficient. And based on the value of R, guys, you can determine how strong the linear relationship is by following one of the outcomes, you know, that I listed there. Is if R is very close to 1, we have a strong positive linear relationship. R close to -1, very strong negative linear relationship. If all the points fall on the line, then R is 1 or R is -1, which is unlikely to be the case. And if R is very close to 0, we say the linear relationship is very weak. And as I told you, I won't have you calculate R by hand. Actually, we used to do it by hand before, guys, years back. It would take 20 minutes just to get the value of R by hand by itself. And here, guys, I explained to you in here and how to do it again, how to find the value. So if you guys, you missed it today, you just make sure to follow this and you should be able, you know, just to do it. Okay. Now what we're gonna do, we're gonna do this, start an exercise with you guys. I'd like you to do this one more time, and then I'll walk you through the process one more time here. Follow my instructions given in this example, because I'm going to explain the whole chapter in this example. So first of all, guys, let X be the age of a child in years, and let Y be the number of irrelevant responses on a standard test appropriate for the child's age. So I would like you to put those values here in L1 and put the other values here in L2. And I haven't done it myself yet, so I'm going to do it with you. So just go to stat, edit, and enter the value. So I'll pause for a little bit, guys, until you get this done. About it again. So how do we do it? I got my calculator. I put the data in L1 and L2. So you go to, you already set up, let me set it up one more time, guys, for some students who didn't do it last time. So let's suppose you're doing it the first time. So you go to second and y equals, you press enter. Let's say this was off on your side. You must turn it on by moving to on using the left arrow key, enter, make sure to select enter here, and then go to type and select the first one. That's it, that's all you have to do. You do it only once, guys, and then you can second and quit. Now to display this, you go to zoom, and as simple, it's the last one, guys, zoom statistics. Oops, sorry. Zoom stat, number 9, enter. Watch, guys. Bingo, there you go. It's very much what you see there. Look, there. What do you think of the linear relationship, guys? Do you agree with me that it looks like strong and negative linear relationship between X and Y? It is strong and negative. Yes. Okay, let's see what R is, guys. Now, okay, here's the first question. We answered that. Part B. These are the questions that it will be asking you. There will be no other questions other than the ones in this example you will be asked to do, guys. The next question will be B. Find the correlation coefficient R and comment on the relationship between X and Y. X is the age of a child and Y is the number of irrelevant responses. You know what, for children, when they're very young and you give them a test, they're just gonna put whatever questions. So irrelevant responses are high when they're young, but they tend to start thinking better, you know, just as they grow older, and the number of irrelevant responses tend to go lower. As you can see that as a child grows up in age, the number of irrelevant responses, you know, just goes down, which is true. Okay, how do I find now the correlation coefficient? For students who did not turn diagnostic on, I'm gonna do it one more time. So you press the second key, guys, and then the catalog right here. And then you go down to diagnostic. I'll do it one more time, no problem. I don't know if there is a shortcut to get to this one, but it's all right. On, you must go to on. Enter, and then enter again. You have to do enter twice. R, no, not R square. R square will come later toward the very end, but it's R. Okay, and now guys, how do I find R? You go to stat, calc, one variable statistics, or number 4, sorry, and then enter. Okay, for students who don't see the screen, just press enter again. But for students who see this screen, make sure X is L1, Y is L2, and go to calculate. There you go. So R is negative 0.97, guys. If I ask you to do it for 2 digits, negative 0.97. And now before even we put the calculator aside, I would like you to write, you know, just Y equals AX plus B and write the value of A and B. Round it to 3 decimal places. So A is negative 0.96. Remember that, guys, 963. And B is 17.296. So not only it gave you the value of R, it gave you the equation of the line, which is going to be the next question. So let me write down the value of R. Find the correlation coefficient R and comment on the relationship between X and Y. Using the calculator by following the steps above, R is negative 0.97. Since R is very close to -1, then there is a strong negative linear relationship between X and Y. As simple as that, guys. That's what you do. Any questions about part B? So part A is sketch the scatter plot. Part B is finding R and say something about R, which we did. And now part C, you already done it, guys. Find the equation of the line of best fit, the regression line. Use your calculator and the steps explained above to derive the equation. So the equation is written in the form y equals ax plus b. Now the reason why we have this hat here, guys, to say that this y was generated from a sample. So every time you write y, you don't just write y, put a hat on top of it, which is ax plus b, or if you want, mx plus b. But the calculator does ax plus b. You already I told you, just copy it down. It's negative 0.963, and b was 17.3. So if you want to write it down, it will be like this. Negative 0.963x plus 17.30. That is your y. It's exactly this. That's what I wrote right here. So we got the equation, which is, as I said, we call it y hat. It's just to say we got this from the sample. It's negative 0.963x plus 17.30. This is a negative slope. A negative slope, guys, means as x increases, y decreases, which is the case in our problem. And this is the y-intercept. Okay, here's a question for you that's going to come later. Y is the number of irrelevant responses, and x is the age of a child. If I ask you, use the regression line, what would be the number of irrelevant responses when the age of a child is 8? So age is 8. If I give you the age, guys, and I ask you to give me what would be the number of irrelevant responses that the child will make on the test, how would you answer this one? Remember, age is x, and the number of irrelevant responses is y, or y hat. So how would you figure out y if I give you x? What would we do? Let's see what students are saying. Okay, I'm hearing students saying replacing x with 8. Exactly. We replace x with 8. And look, this is how we do it. You can do that by hand, guys, on the calculator. So look, I agree. So make x equals to 8. Okay, let's do it. On the screen, I quit. I don't need this anymore. So negative 0.963 times 8 plus 17.30. And here you go. You can see the response, guys. 9.59 responses. You can round this one because number of responses should be a whole number, so you can say about 10 responses. If I give you the same question, guys, and I ask you what would be the number of irrelevant responses if the age of a child was 4, you can do negative 0.963 times 4 plus 17.30. And you get 13.448. You can round this to the nearest whole number. It will be 13 responses, and so on and so forth. So this is how you can use the equation to find x if y is given, or to find y if x is given. On Wednesday, we're gonna do the big part, which I haven't done yet, which is part D here, and how to run a hypothesis test on the correlation. I'm just want to devote the whole session, for it. It's only one question, just to make sure that you understand it. But for the time being, guys, I would like you to go back, review everything we did. You can skip this part here, part D. This is where we do hypothesis testing. So you will, I'll explain that on Wednesday. But what I like you to know for now, how to put data in L1 and L2, how to find the equation of a line, how to find R, and how to interpret R. That's all, guys, that we've done today. And if I give you an equation of a line, if I give you the x value, how to plug it in and find the y values. Practice those things, guys, for Wednesday, and you should be ready to for the important part, which is the hypothesis testing part. It's very easy. It's going to be done on the calculator as well. All 100% calculator driven, but you need, just to practice what I just explained today before we do this. My handout should be very good, guys, to walk you through. What I'm going to do now, guys, I'm going to stick around for students who have any issues with the calculator. I will allow you even, just to share the screen with me of any issues. I can sort them out, just before you leave. But if you're done and if you're good, you can go. Okay, students asking me about chapter 8. 1 second, let me just